Okay, so here we go. Now, here's what he talked about with the distance to the moon. And this was from someone named Aristarchus. And I'd actually not heard of his name before.
I think he was Eratosthenes' assistant.
Oh, really?
Maybe.
Yeah, I don't know. I don't know. But this was another impressively clever idea. So here we need the sun. So now we're going to use that as the sun, and
this is the Earth.
this is the Earth, and then you can be the moon. Okay, well now what does the moon do with respect to the Earth? It goes around the Earth, right? And they noticed that every now and then there was a lunar eclipse. So the sun...
Where they were all lined up.
Yeah, so the sun is casting a shadow, sort of like this. And that shadow distance is 2 Earth radius here. Okay? 2 radius of the Earth.
It's 2 radius of the Earth on the moon orbit path.
Yeah. Yeah, and that...
Is the 2 radius of the Earth the diameter?
The diameter of the Earth, right.
Yeah.
That's right, that shadow is equal to the diameter of the Earth. And the reason it's not looking like I've drawn it correctly, is that we're assuming the sun's super far away and these rays are parallel, so that the shadow doesn't grow like I've shown it growing. Okay? And they noticed that when lunar eclipses happen, that the longest it ever took the moon to go through there was 3 hours.
It never got higher than that.
It never got longer than 3 hours. And he explains what he means by that is that the center of the moon to the center of the center of the moon coming into the shadow to the center of the moon leaving the shadow was never longer than 3 hours. And he's got, in this piece of the talk, he has a lot of footnotes explaining, well, you have to make a little adjustment here, a little adjustment here. So our number isn't going to be exactly what he gets. But that's okay, because we're just making a simple calculation. So they noticed that it never took more than 3 hours to go 2 Earth radius distance. But they knew something else about the moon.
And the moon took its 28 days to orbit the Earth.
It takes 1 month to go all the way around the Earth. And that's 28 days, and then it's actually 29 and a half days if you measure it exactly right. So you have to make all these little tiny adjustments. But this was enough to know. This is very similar to Aristophanes' calculation of the radius of the Earth. We knew it took 3 hours to go 2 Earth radius. 3 hours. 2 radius of the Earth. We know 1 month.
1 month.
Well, 1 lunar month.
Yeah, we'll call it 29.5 days.
That's
Is
the moon orbiting.
2 pi times the radius of the moon's orbit. I should probably call that the radius of the orbit. Okay?
Well,
So how do we go from hours to days?
Well, first we have to multiply this by 8.
Okay.
because that's 24 hours. And
So 1 day,
is 16
16
radius of the Earth.
16 radius of the
We
Earth.
have to multiply this by 25 and a half.
20,
What?
29 and a half.
29. So I'm going to go over here. 29.5 days equals
it's
29.5 times 16 radius of the Earth. And this equals 2 pi times the orbit. Sorry, I'm getting a little cluttered here. I didn't plan this very well. But all this says is I have to divide by 2 pi now, so that the radius of the orbit, this distance, is approximately 29.5 times 16 over 2 pi times the radius of the Earth.
cool.
Yeah. Yeah.
It's
Really cool. Now this works out to be about 75, and the actual answer is about 60 times the radius of the Earth.
Well, he didn't have a lot of technology.
Well, no. We've made some simple approximations here, and this probably wasn't exactly 3 hours, and probably a few other things we have to make an adjustment for.
Yeah.
And when you make those adjustments, that's not important. What's important is this amazing idea
Yeah.
that you could measure how far the moon went here, and you knew how far it went around the Earth, or how long it took to go around the Earth, and that gave you the radius, which is incredible. I mean, this is 2,300 years ago, about, with no telescopes, with no iPhones. Minecraft hadn't even been invented yet. They could figure out how far away the moon was, and they were pretty darn close to being right.
Yeah.
Awesome, right?
Yeah.
Okay, good job, guys.
Good job.